Foreign. Neptune is about 30 times farther from the Sun than our Earth. As the last of the major planets, it orbits the Sun almost in complete darkness. Due to the lack of light, Neptune can only be seen from Earth with very good telescopes. The latest telescope now provided brand new views of this normally luminous blue planet. In this photo from the James Webb telescope, Neptune shines almost as brightly as a star. But where did the glow suddenly come from, and what makes this planet so unique? Let's take a look at the latest discoveries and findings about the enigmatic ice giant Neptune. You have never seen Neptune like this before. The James Webb Space Telescope outdid itself again in September 2022 by capturing a stunning image of Neptune and its rings. This image provides the clearest view of the rings of the distant planet that we have ever had. Indeed, the fine dust rings are not visible to the naked eye. They shimmered ever so slightly in an image taken by NASA's Voyager 2 spacecraft in 1989. But the quality of the image was barely enough to draw more accurate conclusions about the ring's composition and origin. The Webb telescope image clearly witnesses even the fainter dust rings of Neptune. This image was made possible by the near-infrared camera, or NIRCam for short, which can image objects in the near-infrared range from 0.6 to 5 microns. Due to light filtering, Neptune does not appear blue to the Webb telescope but shines brilliantly. The image continues to show 7 of Neptune's 14 known moons. Triton, Neptune's large and unusual moon, dominates this image as a very bright point of light. Triton reflects an average of 70% of the sunlight that hits it, far outshining Neptune. This image is fascinating not only because of its unusual angle of view and its impressive composition. Scientists have gained completely new insights into the dynamics and composition of the planet and its moons. Almost at the edge of our solar system, up to Neptune, the official major planets of the system are Mercury, Venus, the Earth, Mars, Jupiter, Saturn, and finally Uranus and Neptune. Until 2006, we had another planet, Pluto. But since the discovery of more Pluto-like objects in the fringes of the solar system, these many planets have been demoted, the so-called trans-Neptunian objects. The size jump from Neptune to Pluto is indeed huge. Pluto is not even half the size of its neighbor. Because of its remoteness, Neptune is the least studied planet in the entire solar system. For a long time, researchers also thought that Neptune was not particularly exciting because hardly any life was suspected in this darkness, and the ice planet was considered barren and desolate. But this was a mistake. According to the newest realizations, one of the coldest planets in the system could support an ocean of hot water, and in this, even life forms would be conceivable. Neptune is an ice giant about 4 times the size of Earth. It has a radius of about 15,300 miles and a volume of 15 trillion cubic miles, giving it a bottom-line volume 58 times larger than Earth. Neptune's main constituents are water, methane, and ammonia. Like the other ice and gas giants in our system, Neptune has no solid surface. Its atmosphere extends deep into the planet to the mantle, which consists of methane and ammonia ice and a rocky core. Yet scientists believe the ice giant may have an internal warm to even hot ocean. Neptune's secret is that it is by no means as dull as researchers long thought. Scientists became aware of Neptune when they discovered that it has an active climate and some of the most violent and powerful storms in the solar system. The climatic phenomena on Neptune are much more like an oversized rocky planet than a gas planet. Measurements have revealed that Neptune's solid core may be larger and more complex than long thought. In fact, intense geological processes inside the planet can explain the weather phenomena. But not only that, model calculations have shown that Neptune could harbor a warm ocean beneath its ice. Sunlight travels a full 4 hours to reach Neptune's surface. Neptune's average atmospheric temperature is -182 degrees Celsius, making it one of the coldest objects in the solar system. Between the years 2003 to 2018, the planet experienced significant cooling, and at the same time, temperatures at the South Pole rose. In 2018, researchers noticed an interesting change in the chemical composition of Neptune's atmosphere. In this context, these very changes provided evidence of internal heating produced by gravitational compression or gravitational interaction between Neptune and its moon Triton. This naturally raises the question of whether life could exist on Neptune. For a long time, researchers thought that this was not possible. But this view is slowly changing. Since we have found life in the most impossible places on Earth, we have to open our minds to the possibility that life may exist in places in the solar system that we have previously overlooked. For a long time, we searched on Mars, and even Venus will soon be examined more closely for traces of microbes in the atmosphere. But Neptune was not on anyone's radar during this search. Some very brave scientists even suggested that some of the strange spots on Neptune might be caused by swarms of bacteria under the thick ice. This theory currently finds few supporters, but who knows, we may be in for a surprise. Another explanation for the enormous internal energy inside Neptune could have been a collision with a cosmic object. Since Neptune is the only planet that radiates nearly 3 times as much energy as it receives from the Sun, some as yet unknown mechanism must be at work. Another clue is the unusual 28-degree tilt of the axis. The axis tilt is similar to Earth's and explains why Neptune experiences seasons. Unlike on Earth, a season on Neptune lasts not just a few months but a full 40 years. Because of Neptune's long distance from the Sun, the clocks run a little differently here. Not only are the seasons a bit longer than on Earth, but also a Neptune year is a bit longer, at 165 Earth years. However, since Neptune rotates quite quickly around its own axis, a day on the planet lasts just 16 hours. The planet's rapid rotation generates some of the strongest winds in the solar system. Neptune is the windiest planet in the system, and winds quickly assume speeds of up to 1,900 km per hour. This makes Neptune storms even stronger than those on Jupiter. Similar to Jupiter, Neptune also has a large storm that forms a prominent surface. The Earth-sized cyclone was first discovered by the Voyager 2 spacecraft in 1989. In 1994, the storm had disappeared from a new image taken by the Hubble telescope. Instead, a small new spot had appeared in the northern hemisphere. In contrast to the 300-year-old cyclone on Jupiter, the violent storms on Neptune exist only 2 to 6 years. Since Neptune has certain similarities with Jupiter and has a kind of mixture of a rocky planet and a gas planet in its interior, researchers came up with an interesting idea. Neptune seems somehow out of place on its position at the outer edge of the solar system. From the evolutionary history of the planets, Neptune may have once formed between Mars and Jupiter. It's quite possible that some planets in our solar system have exchanged places in the course of time. Thus, Neptune could have been pushed to the edge of the system by the tremendous gravitational forces of Jupiter. Another crazy theory says that Neptune is so different from all other planets because it did not originally come from our solar system at all but was captured as a vagabond planet by our Sun at some point. If this theory is correct, Neptune would be an alien world which quasi-cheated itself into our solar system. Neptune's atmosphere is 80% hydrogen and 19% helium, with the rest being other gases, including some methane. In fact, it is this small amount of methane that colors the planet deep blue. Methane molecules absorb solar radiation in the shortwave region and reflect the color blue. Uranus has a very similar distribution of gases, but unlike Neptune, its color is pale blue. Researchers from Oxford University tried to unravel this mystery in their thesis. They suggested that this difference in color could be due to the density of the methane nebula. Both planets have several layers within their atmospheres formed from fine aerosols. The bottom layer is a mixture of hydrogen disulfide ice. The second layer is probably exactly what turns both planets more or less blue. Since Neptune's atmosphere is much more active than Uranus's, its second aerosol layer is thinner. Because of the lower density, more light is reflected, and this provides the intense blue color. A third atmospheric layer consists of large particles of methane ice. Thanks to James Webb's new image, scientists will unlock the secrets of Neptune's best-known moon, Triton. Triton is a very active moon. Its surface is covered in methane and nitrogen ice. Methane flakes appear, and Triton has very active volcanoes. Researchers have not been able to explain how the heat inside and the unusual volcanism came about. It was thought that the seventh largest moon in the solar system is heated by Neptune's gravity. The volcanoes emit a mixture of coal dust and gas into the thin atmosphere. It is possible that these ejections are involved in the formation of Neptune's fine rings of dust and gas. A very similar process has been observed in the vicinity of Saturn. There, the icy moon Enceladus feeds one of the gas giant's outer rings with tiny ice particles. Triton is special among the moons of the solar system because it orbits retrograde around its planet. This suggests that it may once have been an independent object captured by Neptune. The unusual retrograde orbit and its intense reflection have led to speculation that this moon was originally a Kuiper belt object gravitationally bound by Neptune. Researchers now hope the new image and much more information will finally clarify where Neptune really came from, and when and how Triton became bound to it. It's really exciting what's happening at the very edge of the solar system. It almost seems like every planet and every moon in the solar system has some fascinating property that makes it unique and a worthwhile object of study. We look forward to sharing more information about Neptune and its moons with you soon. Tell us now, what you find particularly interesting about this planet.